Hi, I'm Jinyu Kim, a graduate student and a collaboration of a NEOS experiment. I prepared the status and spectrum decomposition study for NEOS 2. I introduced NEOS experiment, talk about the status of NEOS 2 data and spectrum decomposition study. There are 7 institutes in NEOS 2 collaboration. Purpose. The goals of NEOS 2 are explaining reactor antineutrino anomaly and spectral shape anomaly, especially try to explain so-called 5 MeV bump by using spectrum decomposition method. As seen in left plot, 4 experiments measured 5 MeV bump, and that experiment performed spectrum decomposition method to figure out the origin of 5 MeV bump. NEOS also is planned to perform spectrum decomposition. The introduction of a NEOS experiment. NEOS represents neutrino experiment for oscillation at short baseline. Hanbit reactor unit 5 is used as a neutrino source, and detector is placed in tandem gallery about 23.7 meters from reactor core. NEOS 2 is performed from September 2018 to October 2020, acquired about 500 live days data, including full fuel cycle. There are 2 reactor-off periods acquired about 30 and 90 live days data each. This is the schematic view of NEOS detector. 1 kiloliter of GdLS is used as target material containing a metal tank. Passive and active shieldings cover the target tank. Rated P and lead are used as passive shielding. Muon counters are used as active shielding made of plastic scintillator. Here's chimney for source calibration. For usual source calibration, source is inserted through chimney and located at the center. NEOS 2 detector is operated for 2 years and source calibration was performed bi-weekly. These plots are charge distributions of calibration sources. Simulation fits data well, and by using these sources and other radio activities, charge energy curve is obtained. By using this curve, energy reconstruction is done to NEOS 2 data. Inverse-beta-decay events are collected from NEOS 2 data to measure reactor antineutrinos. IVD criteria contains muon beetle, delayed energy, coincidence time, multiplicity, and PSD cuts. There are stability issues caused by liquid scintillator. Some cuts are time dependent. Details of stability issue are explained in other page. Time dependent cuts are determined for each data. These plots are IVD prompt energy spectrum and IVD rate. Prompt energy spectrum is for reactor-on time for 185 days, and background is subtracted. This is IVD rate. Lamping down and up are seen, and reactor-on and off periods are represented. IVD rate is about 2,000 events per day at the beginning of the reactor-on time, decreased to 1,800 at the end. Background rate is about 80 events per day. NEOS 2 simulation. Tuning is almost done. Now validating is ongoing. Charge distributions are already compared as seen in page 6, and beta spectra for bismuth 212 and 214 are also compared. Confirm the simulation fits data well. As the final step, beta spectrum for boron 12 will be compared. As I mentioned in previous page for IVD criteria, there is a stability issue caused by liquid scintillator. Precipitation is generated in LS. Because of that, light yield is decreased and attenuation gets worse. It makes treating efficiency and energy resolution much more complex. Actually, it was not issued for NEOS 1, but precipitation was also generated when NEOS 1 was finished and detector was opened. This plot shows charge decreasing in several source data, and this is changes of neutron capture time. Charge value is corrected for time, but resolution is remained getting worse. From here, contents for spectrum decomposition are represented. This page explains the concept of spectrum decomposition. The number of expected neutrino events in ice energy beam can be represented as this equation. And this can be simplified as the relationship between fission fraction, fission rate, and IVD yields for each isotope. The number of neutrino events for reactor-on time can be obtained from data. And when constants and fission fraction and fission rate are known, IVD yield for each isotope can be decomposed. This is IVD yield for each isotope. This is fission fractions for each isotope for fuel cycle. A method for separating reactor-on time for data is tested in many ways, and 9 periods are separated based on data run numbers. DIQ efficiencies are obtained for 9 periods, and fission fraction values averaged for 9 periods. We don't have a fission fraction values which fit for NEOS 2 for now. Another values from same nuclear power plant are used. This will be updated in the future. By using this chi-square formula, obtain IVDLs for each isotope, which fit data with minimum chi-square value. This fitting is performed for each energy beam. This term is basic form of chi-square, and this is full term for constraints for fitting parameters for uranium-238 and plutonium-241. Fitting parameters are IVDs for each isotope, and constants are multiplied to give parameters same condition with real data. Constraints are applied by using Huber-Muller model to uranium-238 and plutonium-241. In the contents of this presentation, IVDs are assumed as constants for time, but of equilibrium effect will be considered in future study. Before applying spectrum decomposition method to real data, pseudo data are generated for testing it. Pseudo data is based on Huber-Muller model, and these values are considered. Fitting was done to obtain IVDs for each isotope by using chi-square formula, which is introduced in previous page. Prompt energy spectra for 1,000 of pseudo data are generated and decomposed. There are about 1 million events in the single pseudo data set. These plots represent the mean and standard deviation for 1,000 pseudo data set for uranium-235 and plutonium-239. In the 4 to 6 energy range, where 5 MeV bump can be measured, standard deviation values are about 4% for uranium-235 and 20% for plutonium-239. These values are used as uncertainties of spectrum decomposition method. Summary and plans. Spectrum decomposition method is being tested and uncertainties are obtained. Those two data are ready for the future studies, and when validation for simulation is finished, the results of NEOS 2 will be revealed. I wish I can show you them soon. That's all I prepared. Thanks for watching.